Okay, we're on chapter 13, lesson 2. This is page 831, and we are problem solving, and the strategy today is solve a simpler problem, or you could think of it as breaking the problem down into more manageable bits. Okay, so here's an example of a complicated problem that we're going to solve a simpler or break it down. It takes Jasmine 2 minutes to ride her bike 1 block. How long does it take Jasmine to ride the route shown 3 times? So there's several layers to this problem, and we've got a route where she's traveling 2 blocks, 4 blocks around the neighborhood, and she's actually doing this twice. So that adds another layer of complication to this problem. So what do we know? We know it takes Jasmine 2 minutes to ride her bike 1 block. So, according to the problem, 2 minutes, as stated right there. How long will it take her to ride the route 3 times? Well, we'll solve a simpler problem to find the answer. So, first I'm going to go and add up 2 plus 2 plus 2 plus 4 plus 4 plus 2, which will get me back to where I started. So that's what they've written out here. 2, 4, 6, 8, 10, 12, 14, 16. 16. Jasmine rides 16 plus 16 plus 16, or 48, because she rides it 3 times around. So that's why they tripled 16 here. Now, if it takes her 2 minutes to ride each block, we're going to do 2 times 48, the number of blocks she's ridden 3 times, and we're going to get 96 total minutes. So it takes Jasmine 96 minutes to ride around 3 times. And basically here was where we did the easier problem. We just broke it down into doing it 1 time, and then we were able to figure out for 3 times after we've done the once. And once we know how many blocks it is, then we can figure out, okay, this many blocks, this many minutes per block gives us how many. So you've basically got a 3-step problem here. 1, 2, 3. Oops, that line should go there, sorry. So that's how that one's done. Okay, and I noticed on my other videos when I was not doing this one, most of you were not doing this one. So I'm going to get you started and then leave you to finishing up this one once I've given you a little bit of support to get this done. Hayden and his friends want to draw a court on the playground to play Foursquare. The sides of each of the small squares are 4 feet. So these are perfect squares that are 4 feet on each side. What is the perimeter of the entire court? So first, what facts do we know? I can go back, and if you have your highlighter, you can, instead of writing it here, you can just go here. And then it also asks, what do you need to find? And the question is always, what do I need to find? So I'm just going to switch this around from a question to a statement. I need to find. And then the plan, just as in the other problem, we have given the direction to and that's the plan. So what you're going to do in this space is show your math work down here, and then at the bottom you can write your complete sentence answer using both the question and what you wrote here for what you need to find. And that will help you there. Check to make sure. You can work it backwards and put it in. A lot of times just writing the sentence will help you determine if your answer makes sense. So that will get you through this one. Now we've got some different word problems that involve finding perimeter. So Clarissa has 4 pictures that are each the size of the one shown. What will be the perimeter of the rectangle formed if the 4 pictures are laid end to end as shown? So what A common mistake that happens on this is somebody will figure out the perimeter of this shape here and get that, and then they'll just multiply it times 4. That doesn't work. And the reason it doesn't work is because this side and this side and this side have been sort of not exactly overlapped, but they are double counted if you multiply it by 4. So you're going to end up with a perimeter that is much bigger than your actual perimeter because you've double counted these sides in the middle here. So you're going to have to take and continue on the pattern that you're going to see here. If this is 5 and we know that each picture is exact same, then that means that this is also 5, and so is this, and so is this. So all 4 of those together makes 5, 10, 15, 20. And then if this side is 20, then that means this side is also 20. And if this side is 3, then that means what about this side? So that should give you the lengths of all 4 sides of this larger rectangle, complete sentence answer on your line here. And you can write them there to help you remember them. You don't necessarily need to show any work in here. So number 2, Mr. and Mrs. Lopez are putting square tiles on the floor of their bathroom. They can fit 6 rows of 4 tiles in the bathroom. How many tiles do they need to buy? If each tile costs $5, what is the total cost? So I'm going to draw some things in my work center here and show you a good way to set this problem up. So this is just to help us visual learners even figure out what we're doing to make a simpler problem with this. So they can fit 6 rows of 4 tiles in the bathroom. So what I've shown here is 1, 2, 3, 4, 5, 6 rows. And if I wanted to draw the full grid, I would draw 4 tiles in each. So that's basically what it will look like following this direction that they've given us. 6 rows of 4 bathroom. Okay, so first we need to figure out how many tiles they need to buy. So that's, let me change the color here. So this is the first part of the 2-step problem. How many tiles do they need to buy? And we're going to use, since I did do 6 rows and 4, we can do our unit counting to figure out how many. You can either, even if you need to, you can count every single rectangle, or you could just multiply across and up and down. And that will tell you how many tiles they need to buy. And then once you've got that, you also need to figure out, this is the last part, if each tile costs $5, what is the total cost? So you've got multi-layers there, and you're going to need to break it down into smaller pieces in order to be able to get your final answer, which you can write on the line. So a good sentence that you might want to think about using here to show that you've done all your steps. How many tiles do they need to buy? That would be answered with this one, using blank tiles at $5 each. And then to answer the blue question here, if each tile costs $5, what is the total? At $5 each, they'll need X amount of dollars at the end. So that's a sentence you could write. That's a visual that'll help you figure out what kind of operations you're doing and the 2 steps that you're going to break the problem down into to solve easier problems. Hopefully that helps. Number 3, Ling is putting up wallpaper border on 3 walls that are each 14 feet long and 12 feet tall. How many feet of wallpaper border will she use if she puts the border only at the top of the wall? Okay, so I tried to make a little visual representation here. So I just basically flattened out 3 walls of a room. So these would be 2 sides, and this would be like straight ahead or something like that. But I just flattened them out to show the 3 walls all laid out like a just on a flat surface. So they would be 12 feet tall. So each of these would be 12. Okay, sorry, something's just going really slow right now, but at least I got the 4, or I'm sorry, the 14 measurements of these walls. And again, because it's a rectangle, we know that this side would be the same over here and each of these lines in the middle. And if this is 14 here, then so is this, which is also true for this and that. Okay, so now the thing that's tricky about this one is we're not going all the way around all of each individual rectangle, nor are we going all around the perimeter of the full 3. The directions here say how many feet of wallpaper border will she use if she puts the border only at the top of the wall. So we're not going all the way around anything, we're just going across the top of these. So that's going to be a different thing to figure out than what you might want to do. You're probably going to make that one more complicated than it needs to be. Okay, so hopefully that helps and doesn't confuse you even more. Okay, Takesha is placing 72 photographs in an album. She will put the same number of photos on each of 6 pages. She can put 4 pictures in each row. How many rows will be on each page? Okay, so you've got a couple steps that are happening here. First, you're going to need she's got only 6 pages and she's got 72. So you're going to need to section out or divide those 72 photographs onto those 6 pages. From there, you know that you can put 4 pictures. So then you're going to again divide up those pictures for each page into each row. So you've got 2 steps there that you're going to need to break down. First, solve the pages. Once you get that answer, use that answer to solve the question for each row. How many rows will be on each page? Okay, so hopefully that helps you. You might need to re-listen to that, rewind and play again to make sure that you're really understanding the different steps you're going through to get that one. Okay, so what we're looking at, this problem. This is a really awesome problem because it's looking at a very simple version of something that is going to become a big part of your life in later on math, and it's called squares. I'm just going to give you a little tip. You might have seen something where you've done like 3 squared, where it's repeated multiplication. Like multiplication is repeated addition. This is repeated multiplication when you've got the little exponent here, which is what that figure is called. So these problems are looking at squares, which is why each shape that is shown is a square. This one has 1 on each side. This one has 2 on each side. This one you'll see has 3 on each side. So this one would be the 3 squared that I wrote over here. This one is, surprise, surprise, 4 on each side. And that's also, oops, silly, 4. That's also the 4th pattern. So you need to get to the 8th figure, which is going to have 8 and 8, right? Hopefully that will help you figure it out. And notice that there is a reason that that's happening that way. And it's going to be a big part of math, as I said, later on. Okay, so work on that one. Number 6, Marcos is making 3 tile pictures. He uses 310 green tiles to make each picture. He uses 50 fewer red tiles than green tiles for each picture. How many red and green tiles does he use in all? Okay, so looking at this one, what we've got is first we know, the thing that we know for sure is that there are 310 green tiles. So let's latch onto that. That's going to be the first part that we're going to use to solve the whole problem. And this is the first step of this multi-step problem. Then it says he uses 50 fewer red tiles. And since we need to know all of the tiles, and we're saying red and green tiles, we also need to know how many red tiles that is. So we need to do something to figure out how many red tiles. And here we know these are green. Okay, it says 50 fewer red tiles. So that means I'm going to subtract 50 from the green tiles. Do my subtraction, 0 minus 0. Regroup from the hundreds place, 2 hundreds to make 11 tens. 11 tens take away 5 tens is 6. 2 take away 0. So this means there are 260 red tiles and there are 310 green tiles. So then we need to add in the 260 plus the 310. So there's our red tiles, there's our green tiles. And when we get this answer, that will tell me how many red and green tiles he uses for one picture. But it's not asking one picture, it's asking three tile pictures. So this is not our final answer either. From there, we need to take that picture and multiply it by 3 to find the total number of pictures, or I'm sorry, the total number of tiles that are red and green that he uses in all of his pictures. So that's the breakdown of how that one. I did basically the first step for you, got you through most of the second step, and then you can solve the third step to get the final answer on that one. Okay. A type of bacteria doubles in number every 12 hours. So that's already going to be like our squares up here. After 2 days, there are 48 bacteria. How many bacteria were there at the beginning of the first day? So one of the steps you're going to need is how many 12-hour increments are in 2 days. 12, 24, 36, 48. Okay? And then see if you can work backwards to get from the 48 bacteria at the end of 2 days and get back to how many that was to start with. Hopefully I didn't give you too much of a clue with that one. Martel had boxes he was stacking. Each was 2 feet high. If he stacks 3 boxes on top of a table that is already 3 feet high, what will be the total height of the boxes and the table? Okay, so you may want to draw yourself a picture over here of a table and then some boxes that are on top. It says 3 boxes on top. And then figure out the measurements for each and the table, and that'll get you the total height of the boxes and the table. For us visual learners, we need to do things like that. And that will definitely get you the right answer and the right operation. Okay. Mr. Waters is building a rectangular sandbox. He needs to buy enough wood to go around the perimeter of the sandbox. If the length is 6 feet and the width is 5 feet, how many feet of wood does Mr. Waters need to buy? Okay, so that's just a perimeter question in order to get around the perimeter of a sandbox with a width of 5 feet and a length of 6 feet. And then figure out the other 2 sides based on the properties of rectangles. Okay. And if you haven't already spent your hour, you're going to be looking at the back of the homework. And there are 2 identical figures with all sides of equal length. And I'm just going to mark that for you because that's going to be a key piece of information you're going to need to figure out the question. The combined perimeter of all of the figures is 80 centimeters. What shape are the figures? What is the length of one side? So knowing that all of the sides are equal length should tell you right away what shape it is we're talking about and what is the length of one side. Now when you get into higher math, you'll know that if you've got your parents helping you, you might see that there are actually other shapes that are out there that are possible, but given what we've been using in these lessons, we've been using rectangles and squares, so that narrows you down considerably as far as your options and makes it more clear what exactly the shape that you're dealing with, and then you can break that down to figure out the length of one side of this shape. Okay. Miranda packed 19 glass ornaments into each box. She filled 5 boxes. What is the total number of ornaments in the boxes? So you can either do repeated addition or you could do multiplication in order to figure out the total number of glass ornaments in all 5 boxes. Now we've got Carrie is making a bed skirt for her twin beds. One side of a mattress measures 39 inches. The other is 75 inches. So given the shapes that we have been dealing with, what kind of shape is it that the mattress is? It's the same as the shape of your mattress. How many feet of fabric will Carrie need to make skirts for both beds? So figure it out for one bed, that's your first step. And then figure out for 2 beds. You can either add them up or multiply. Okay. Dalton's dad rode his bike 1 kilometer north, 1 kilometer west, 1 kilometer south, and 2 kilometers east. How many total kilometers will Dalton's dad ride if he follows this path 9 times? Okay, so take into account 1 time around the path and then 9 times. So hopefully that helps you with that one. For each mile that Jason runs, Megan runs a quarter mile farther. If Jason ran 6 miles, how far did Megan run? So if I were going to make a visual model of this, I would draw out 2, 3, 4, 5, 6. And since Jason ran those 6, that means Megan ran 1 1/4 of each of these. And then I would use that to figure out what kind of operation I wanted to do in order to find the answer. Hopefully that helps you as well. Okay, great job. Keep up your hard work, and I will see you for corrections.